Let's go. I need to come clean with you. I have a challenge. And the challenge is I've been coughing like, I don't know, somebody who coughs a lot for the entire day. So I have specific instructions to turn off my microphone whenever I cough. So it stays here and it not goes to the speakers to all your ears. We'll see how far we go. I have some sounds. I need to do a sound check. Let me know if you recognize the sound you hear. Mario always helps, right? So we're going to talk serverless. My name is Bert Jan Schrijver. I'm CTO at Open Value, and I do some stuff for the NLJUG that probably most of you are familiar with. So I can skip this slide because, well, most of you are probably a member of the NLJUG, and most of you probably also know this app. How many of you have this app installed on your phones? Okay, if you don't, feel free to do it right now. So we can all test that the voting system works at the end of the session. It works best if you give like 5 stars, I've heard. So this app was created by the Dutch tech service, so thank you all for your contribution to this app. Well, you know how it looks, right? So you can pick conferences. There's some details about a conference. You can view the sessions, open session details, and you can rate sessions. Sorry, I forgot to mute it. So the app takes its basically static content, so all the session descriptions, the images, the speaker images, takes it from S3, which is a scalable object store by AWS. So that's basically infinitely scalable, and it's only static content. So we use Sessionize for our call for papers. So speakers enter their proposals there. We create a program in Sessionize, and then basically I have a tool that pulls the accepted sessions from Sessionize, uploads to S3, and the app fetch from S3. That's all static, so not super interesting. So the backend is where your votes get sent when you vote for a session. So the first iteration, and we're talking almost 10 years ago now. This was built with technology that was common 10 years ago. So it's Java EE, Wildfly 8, and Java 7. It was running on Amazon already then on a MySQL database. So basic VMs, Linux VMs on Amazon, with a load balancer font, so I could scale out a little bit. It was running probably for a long time on like 3 or 4 small instances. This worked fine, but the problem is that even a load balancer will set you back around $35 a month. And well, this app is not used much. It's used during JSpring 1 day a year, JFall 1 day a year, and TechNation 1 day a year. So if you're paying $35 a month for the rest of the year, well, that's not really money well spent, right? You can better spend it on gadgets and, I don't know, other things. But it worked, it was fine. So what I usually did was build this up a couple of days for the conference, run it during the conference, scale it, and then throw it away again after the conference. So at that time, I was working at the Dutch police together with Tim. So Tim is the guy standing on the left here. And Tim said, I built this together with the tech service with Wildfly and stuff. And Tim said, yeah, you're doing it all wrong. I said, oh, really, Tim? So what's wrong? He said, yeah, this is the ideal use case for a serverless application. You're using this only 3 times a year, and now you have infrastructure that's always continuously running. So I said, okay, but what is this serverless? How does it work? Well, serverless computing, you're basically deploying functions, so small units of executions. It's also often called fast, functions as a service. They are short running, so typically a function runs for the duration of 1 request or a couple of requests, which is usually different from your, let's say, enterprise app, Java or Spring, that runs for days or months. Small units of execution, so not an entire monolith that starts up, but small things. It's on demand, so a serverless function typically starts up at the moment you get a request in. You pay per use, so at Amazon you pay for CPU, second, memory, megabyte. So the amount of CPU time you use and the amount of megabyte memory you use. And they scale back to 0. So if something scales back to 0 and it's on demand, there's one thing that matters if you don't want your customers to wait for too long. If we scale back to 0, we need to start up for every request. What matters? Startup time, right? So if you take a typical JVM, you run Wildfly 7 on it, and you have your users wait until the request is handled. Are your users going to be happy? No, this takes, I don't know, an hour or something, right? So even if you do WebSphere, it takes a long time before it says, ready for e-business. I always love this in WebSphere that it said that. And even with a you know, a bit more modern stack, a modern Java version and Spring, you're in the order of magnitude of seconds for startup time. So this used to be an issue in serverless computing. So, well, yes, startup time matters. For cold starts, so Lambdas or serverless functions often keep a function running for an amount of time where no requests are coming in. So it starts up your function, it handles the request, then typically it stays running for like 15 minutes or so until it gets scaled down to 0. But still, if it shuts down after 15 minutes, you're still going to have a lot of cold starts for a conference backend app. There are still servers. So serverless doesn't mean there are no servers, unfortunately, but you don't really care about the servers anymore. They're now abstracted away. You're only deploying a workload, and in my case, the cloud provider handles all the server stuff. So my first serverless experience was in 2016. I got an Amazon Echo, and then I wrote a couple of lines of Java code that could have it do something. At that time, I think you needed to compile the Java code on your own machine, and then upload the jar files to an Amazon web interface to get it running. Not really continuous delivery yet, but this was the result. Amazing, right? So this was my first experience. Well, then it was time to modernize the app backend a little. So at that time, I think Spring Boot 2 was just out. So I migrated to Spring Boot 2, Java 8, still running on AWS EC2. So these are basically Linux VM that you deploy, load balancer in front, and then I switched to DynamoDB as a backend. So DynamoDB is some sort of a NoSQL database. It's a key value store. So in this case, the key is a vote for this session on this conference, and the value is the vote. At that time, DynamoDB was not auto-scaling and serverless yet, but Amazon calls it auto-scaling now. So you don't really need to worry about how much capacity you provision. So before, I needed to configure something like, I want 10 read users and 10 write units, and if you would go over this, it would lock up. Now you can just say, do whatever you need, but don't break the bank in how much money you bill me, Amazon. So overall, the infrastructure was very much the same, but now it was Spring and Java 8. And then Tim said, but you're doing it all wrong. I said, yeah, Tim, I know. You told me about serverless and stuff, and but I needed to start looking into serverless. I was just lazy and hadn't done it yet. So my first attempt was in 2019. And in 2019, I took a piece of Java code, I think a Vertex how-to that was created by Paulo Lopez, who was also speaking here today. And then GraalVM had just come out, and I managed to take this Vertex app and this Java code and compile it to a GraalVM native image. I'll get into what that means later. And deploy it to Amazon Lambda. But it was a hassle because I needed to compile it on the same target platform as I would run on. So I would start up an Amazon Cloud virtual machine, copy my code there, compile it there, download the compiled binary, put it on my laptop, open the web interface, upload it, run it, and then after I'd gone through all this, I was thinking, I'm not going to do this a second time without automating it. So GraalVM, it's a Java development kit and a Java virtual machine. So you can basically compile Java code and run Java code. Oracle builds it, and there's two options to use it as a runtime. So you can run it as a Java virtual machine. So it's based on the hotspot VM, and then it acts basically like your regular Java virtual machine, and it has JIT, which is just in time compilation. So your virtual machine starts up, it compiles your Java bytecode to machine code for your target platform, runs it, and then the JIT kicks in, it starts analyzing your Java code for possible optimizations, make those optimizations, recompiles, and compiles to machine code. So the JIT is a marvel of engineering, and it's one of the reasons that the Java apps that we all write perform so well. A reason why it doesn't is because, well, databases are hard, but well, on the Java side, it's all pretty fast, right? But it can also work with ahead-of-time compilation. And with ahead-of-time compilation, you're compiling to a platform-specific native image binary, which is a mouthful, right? So what we're doing here is we're taking, well, basically GraalVM. GraalVM takes your Java bytecode, so you first compile your Java source code to Java bytecode. GraalVM takes your Java bytecode and then start compiling this and doing the stuff that the JIT typically does when your app is running, but now doing this before it runs. So this is the ahead-of-time part. So it takes your Java bytecode and directly compiles it into machine code for a specific target platform. So a native image is always for a specific target platform, let's say Linux x86, or in my case, it's ARM, because I have a M1 Mac that has an ARM processor. So what you're doing here is you're skipping the entire Java virtual machine step. So traditional applications, Java source code, you compile it on your local machine to bytecode, you run it on a JVM, JIT kicks in, makes platform-specific machine code. The whole JVM and JIT stuff you're skipping with native images. So you're compiling your Java bytecode to a native binary that runs on a specific target platform, which has all kinds of advantages that we'll see soon. So in the meantime, and this is DevOps Belgium 2019, Tim is presenting at DevOps Belgium about serverless stuff with Quarkus and Amazon Lambda. So after ranting to me for years that I need to do serverless, he was doing serverless himself. So I said, I need to step up. I cannot have Tim say to me again that I'm doing it all wrong. So second attempt, I started looking at Quarkus, because Quarkus had come out around that time. Tim was using it, and when Tim uses it, it's typically pretty good. So Quarkus is pretty useful for doing stuff on Kubernetes, open source, Red Hat builds it. It's designed to work with the Java ecosystem. So all the libraries that you know from whichever framework you use, most of them work with Quarkus as well. Lots of stuff from the Java EE ecosystem works as well. It's tailored to run both on OpenJDK hotspot, so then we're in virtual machine mode, but also on GraalVM. Developer experience is pretty cool. I'll show you in a little. So my second attempt was, well, there was, I don't know, like a pandemic in between, and I didn't need a conference app for a couple of years. So my second attempt was in 2022. Then I took Quarkus and GraalVM and Amazon Lambda, and it was pretty easy to get something running there. So I created a small skeleton project that you can still grab from my GitHub that makes it easy to build and deploy stuff to Amazon Lambda. But there was a but. I was building this on my M1, which is an ARM processor architecture. And at that time, Lambda only did x86. So I was, while building it, I could cross-compile it in a Docker image to Linux x86 on my Mac ARM M1. And that was slow. It took like half an hour or something to compile. So I'm like, I'm way too impatient to do a build and wait half an hour, right? So kind of stopped again then there as well. But then a year later, which was last year summer, then I found that Amazon now supports ARM runtimes for Lambdas. So now I don't need to cross-compile anymore. So I can take my laptop, build it here in a Docker image, get a native binary that directly runs on an ARM runtime. And that's pretty fast. So I upgraded this skeleton project on June 10, and then June 14, a couple of days later, I migrated the whole backend from Spring to Quarkus on native images, which was pretty quick, I think. So this all took place at some open value hackathons where we basically hack on projects and, I don't know, barbecue in the evening. So Tim was finally happy. This is happy Tim, because I'd finally done what he'd been saying to me for years. So the third iteration of the backend, well, the overall images look pretty much the same, right? It's still DynamoDB on the right. Now it's a Quarkus app. It runs as a GraalVM native image on Java 17, AWS Lambda, and there's an API gateway in front, which is pretty much the same as a load balancer, but it costs way less. So it's time for a demo. Let's start, and there's a guide you can use to start, which is Quarkus Amazon Lambda HTTP guide. There's a nice blog there, and I'm going to scroll down to a part where it says, if you want to use the REST API, you can generate your project with this script. So let's go ahead and generate it. So this is a Maven archetype that will generate a project for me. And let's, I don't know, type a group ID. Going to call it Lambda demo. Sure. Okay, generated, Lambda demo. Ooh, that's loud. Open it. Oh, I made a typo. I'm not sure what IntelliJ is going to do now. It's open a file called C, I think. Nice. So what it generates a POM file for you. And in this POM file, there's the Quarkus stuff is defined. There's the Quarkus platform artifact. Then you can choose which kind of web engine you use. So you can do REST Easy, which is basically Jakarta EE JAX-RS. You can do Undertow for servlets. You can do Reactive for Vertex Web, and you can do funky, which is, I don't know, some funky thing for functions that run on serverless, right? I'm using Amazon Lambda REST, JUnit, rest assured is in there, that's basically it. So what you get is a couple of source files generated that all do the same thing. So this is with funky, this is JUXRS, this is a servlet if you're feeling old school, and this is Vertex if you're feeling reactive. So I'm not going to continue in this project because I created, like, as I said, this small skeleton project. And this is called Quarkus GraalVM and AWS Lambda ARM64. So what you have here is the same POM file. Pretty much, I think, exactly the same stuff is in there. I think I only went for Quarkus REST Easy. So I'm doing JUXRS style REST endpoints. REST Easy JSONB for JSON binding. So you're binding JSON back and forth to POJOs. Lambda REST, JUnit, I guess that's about it. And then there's a simple resource that sends on /hello, sends back plain text, hi from NLJUG. So the Quarkus development experience. I already had it running, but let me show you what to do. You say Maven Quarkus dev, and then start your project in development mode. So now I can go to localhost 8080 /hello, and then it says hi from NLJUG. But now if I want to change it and I say, I don't know, hi from JSpring, right, refresh, and then it should work right away, hi from JSpring. So it auto-reloads so fast that you can just, type, reload, and go. I'm going to switch it back, otherwise my integration test will probably fail. So what next is I'm now going to build a native image. So I have a script for this. Let's go to the right project. That's over here. Build.sh, so this is going to run a build. Let me show you what's in the script. It says Maven package -d native, so it's now going to use a container to do a native image build for my project. So first, it does a regular Maven build, it runs the integration test, so then the bytecode is there. Then it starts up a Docker container that's going to run a native image build. So what's it doing is it's loading my app, and analyzing the bytecode and then turning it into a native image binary, which means that the whole application is going to build into one single binary. And that binary has everything you need. So all the stuff that would be in the JDK, your source code compiled, obviously, any of the Quarkus stuff that you need, it's all in there. There's a lot of work, so it takes a little, typically around a minute or so. So let's see. Yeah, we need to wait for it to finish, but that won't be long because, well, about a minute, right? I can run it, run local. So run local uses something called Amazon SAM. I'll show you a bit more about this. So SAM is the serverless application model. It's a tool, basically a file format for describing serverless apps and a CLI for deploying those apps. So now I'm running my native image. My Quarkus app compiled to a native image locally. So if I go to local, it runs on localhost 3000, I think. I should be able to see it, yeah. So localhost 3000. So what it does, it starts up a Docker container that has basically the same runtime as Amazon Lambda, copies my app in there, and then good to go. Localhost 3000, hello, that should do the same. Takes a while to start up because it's like uncompressing the Docker container. Well, that works as well. So now it's pretty close to running this as a native image on Amazon Lambda, but I'm running it on my local machine. So, well, I'm going to let you guess. This is this application. It's well, a resource. Quarkus libs are in there, JUXRS in there, JSONB, all the stuff that's usually in the JDK. So how big do you think this zip file is? So it created a file called function.zip. Let me make a file and unzip it. It's already there. One file is in there, bootstrap. So that's the whole thing. How big do you think this function.zip is? Okay. So it's a Linux ARM ELF binary, I think. So what's in there is all the Quarkus stuff, my stuff, and the stuff that's usually in the JDK, which is around, I think JDK is like 100 meg on disk or something. I think Guno was pretty close to the answer, 19 megabytes, right? This is compressed. So if I see the binary, 57 megabytes. So, well, if you said 60, then you're pretty close as well, right? Depending on whether you zip or unzip. Which is pretty small, I'd say. And this is one of the reasons that native images also have quite a low memory footprint. So there's only so much memory you can use with a binary of 19 megabyte, right? Unless you, I don't know, start calculating pi or something, but we're not going to do that today. So I'm going to deploy. I have a script for this, obviously. Deploy. So it's going to upload the function.zip to an S3 bucket and then start a CloudFormation run. So CloudFormation is Amazon's infra as code tool. And it's going to create all kinds of stuff and give me some updates on how things are going. So now I have some time to show you through the config files here. Let me get rid of this. This is the config for SAM. So SAM, the Serverless Application Model, is both a file format, which looks like this, and it's the SAM CLI. And the SAM CLI is based on the AWS CLI. So I have on my machine the AWS CLI configured with my credentials in there. So it says that the stack name for CloudFormation is called Serverless API. We're going to EU West 1, which is somewhere in Dublin. Some other stuff, I have no idea what it means. And here are YAML files. So I do know what the YAML file means. So this is some initialization stuff. There's some stuff commented that I'll get on later. So we're going to deploy a serverless function. It's going on ARM64. There's no specific handler because I'm not using any of the runtimes provided by Amazon. I'm using the Amazon Linux 2 runtime. I'm deploying a function. Max memory is 256 megabytes. Timeout is 15. I'm not sure if that's minutes or seconds. Probably minutes. I'm going to send events to an API. And I'm going to deploy an API gateway. It has a stage name. So a stage name is something that comes behind the slash. So you can make like dev, acceptance, prod stages. Some parameters. And the parameter for stage defaults to prod because, well, YOLO, we only have production here. And there's some outputs. I'm outputting the API gateway URL and the name of the CloudFormation stack. Well, it's done. It says it's deployed here. So if we go to this URL, then we may be able to see something, /hello. So now my native image is deployed to AWS. You haven't seen anything from AWS yet, right? So, well, let's show you a little. So if we go to Lambda, there's a Lambda deployed, and now it's called Serverless API something something. And this gets triggered by an API gateway. So if we jump to the API gateway, and there's an API gateway that has an API endpoint that you just saw because I showed it in the browser. And if I jump to the API gateway, I can show you how it's configured. So the API gateway basically provides me a URL that transforms HTTP requests into events that my Lambda can handle. And because my Lambda understands REST, basically I don't need to do any request mapping or something. So here the API gateway proxies any request it gets to a Lambda, basically the Lambda that I have here. So API gateway takes HTTP request, converts it to an event, sends to a Lambda. Lambda processes it, sends back a response. The nice thing about this is that my development experience, locally building the stuff, is not different from any other Quarkus or Spring development experience. I'm just building a REST application. It could be a REST microservice on my machine, but it's compiled as a native image and built and deployed to AWS Lambda. So let's see. We got all this, yes. I can show you even logging. So scripts, get logs. That will probably say something like SAM get logs. So this is the startup logging from Quarkus. It started up in 0.16 seconds, which is not too bad, right? And it built here 528 milliseconds and then the max memory size. And it used 67 megabytes. So can you run a JVM in 67 megabytes? Probably not, right? It should be pretty small. So, I don't really like this domain name. This domain name that says blah, 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 execute something. I want a nice domain name. So we're going to add a custom domain name. I have this already configured here. We want TLS, so we're going to make a certificate. So we're going to instruct the AWS certificate manager to generate a TLS certificate. We're going to reference we're going to add a domain, so a custom domain to the API gateway. The domain name is a reference to a variable, and a certificate is the certificate ARN, which is the resource identifier, is a reference to the certificate that we generate. So you can make references in this language as well. And in the output we have here, I wanted to output the custom domain name in case I forget the URL, which is here. And this was the value of the parameter. So you can also define basically like variables in your SAM scripts. So now we can run the deployment again. Basically, you say scripts deploy again. Now it says that it doesn't need to upload my file because I didn't change my native image, right? So it says, hey, the file's already there. I'm only uploading the CloudFormation template. So now it's going to delete my deployment, add a new one, add a certificate. Well, that will take a while. We can go to the API gateway in the Amazon console and see whether it's already generated the custom domain name. That will typically take like a minute or something. No, it hasn't, so I have some time to drink, which is good. So it's creating a certificate here. It's creating a deployment. And then the API gateway stage is now updated. So probably next is it's going to create the custom domain name. Yes, here we are. So let's hit AWS with a nice refresh. Yes, so now the custom domain name is configured. So this is a domain name that now the API gateway listens to. But we need to update the DNS of OpenValue.dev to point to this domain name. Because well, I just created the API gateway a little while ago. So let's assume that the DNS is managed somewhere else. I'm getting this, the host name of the API gateway. Then I can go to my DNS manager. In this case, it's hosted on AWS because that makes stuff simpler. So probably I would be able to automate this all as well, but well, I was lazy and I didn't do it yet. So now I'm going to update the DNS entry for demo Bert Jan 1. Let's see. Well, I need to go into this zone, and then it's the serverless API something something, and I can edit the record and put the new domain name in there. So now serverless API.demo.bertjan1 points to this URL. So the API gateway is already listening to this URL. There's a certificate configured that is a certificate for this URL. All we need to do now is be patient and wait until the DNS has been updated so we can access it. This may take a minute or so. So let's see how fast we are. Well, it works already. So now we have a custom domain name. There's a certificate that's probably provided by Amazon, I guess. Yes. So now it's like a full-fledged application running here. But I see you thinking, can you do, this is only text. Can you do JSON or Marshall Java LPX, right? Well, let's see if we can. So if we go to the resource here, I want to add something that's just a little less trivial here, right? So let's, well, this is an app backend, so let's make a new class. Well, let's go for a record. Let's add some speaker info to our app backend. A speaker has a name and a, I don't know, a tagline. So now we're going to make a new resource here. If I go to my local machine, it should be still running. Localhost 8080/hello. Oh yeah, there was this issue that I ran into before where if you open the dev UI, it gets stuck. So I need to fix this. Probably something that was, I don't know, recently broken in Quarkus. If I access directly, then it should work. Yeah, so this says hi from NLJUG. So the backend is running. If I now update this REST endpoint here, I should be able to refresh it quickly without needing to restart. So the new path for this thing is /speaker. And we're going to do JSON instead of text. It's going to return a speaker object. The method name is speaker, doesn't matter what this is. I'm going to return a new speaker. Let's say it's me. And this is my tagline. All right, so if I now go here to hello/speaker, then it should be there, right? Yeah, that works. So we have the JSON output here. So the marshalling stuff works like you would expect. Let's now build it and deploy it. And I'm going to let you guess how long this takes. So I'm going to do a full build and a deploy and time it. So it needs to run my tests, build a jar file, upload build a jar file, build a native image, upload the native image to S3, then start a CloudFormation run, deploy it, etc., etc. So to prove you that it's not here yet, can go to my custom URL and says resource not found on this URL, right? How long do you think it takes? Integration test, Maven build a native image, upload to S3, do a CloudFormation run, update all my stuff. 90 seconds. I hope it's not 30 minutes because then we're going to be late for drinks, right? 90 seconds is pretty accurate, I think. It's not done yet, but we haven't spent 90 seconds yet. It's now building the native image. And after native image is going to trigger the deployment. This should be done pretty quickly. All right, uploading. And now initiating deployment. So now it's basically, the only thing it's doing is uploading a new version and telling the Lambda to deploy a new version. So the API gateway will stay unchanged. So I can start refreshing here because I'm impatient. Not yet, not yet. It was /hello/speaker here. So it's already there. I got lucky. Well, CloudFormation still thinks it's busy, but it took 1 minute 32, so 90 seconds is pretty spot on. If I want to get rid of everything, I can say destroy everything. And it says SAM destroy, so I want to get rid of serverless API. Clean up behind me. So it's going to down and delete all the templates that were uploaded from to S3, delete the CloudFormation stack, etc., etc., etc. Okay, did I show you everything I wanted to show you? Yes, yes. Hope so. So now that I had this template running, I needed to migrate my application from Spring to Quarkus. So on the left here, you see how it was in Spring. It's there's a voting service that does the voting that's injected. It's a REST controller. It has like a post mapping, pretty regular stuff for Spring. So how does it look in Quarkus? Well, pretty much the same. It's just the Jakarta JAX-RS annotations, right? So I'm doing @inject to use injection via CDI. It's a post. There's a path in there. I added security, so it has now permit all for security. Produces JSON. Left and right pretty much look identical. So that was doable. Then the data classes. So before I used Kotlin because, well, I wanted to be one of the cool kids who use Kotlin. And then when I was playing with this, Jago, one of my colleagues, came to me and said, yeah, we're now Java 70, so you don't need Kotlin anymore, you need to use records. I'm like, do you know about records? Let's see if I can get Kotlin working. And then after 2 minutes, didn't have Kotlin working, so then I chose records, and records work right away, so now it's records. So it's a record that basically is identical to the data class in Kotlin. So this I needed to translate a little as well. Then the other stuff I need to do, I have video material for me looking for the other stuff that I need to change. It worked. That was basically it. So I can show you some of the code from the actual production stuff that's processing your votes right now. This is the POM file. That's pretty much the same as the template project that I had. There's the Quarkus stuff in there, REST easy. Then there's some stuff to connect to DynamoDB, some stuff to read something from a property file. Quarkus Arc is dependency injection. I have some caching in there, Quarkus cache. I have Qt, which is a template engine to do like templating in HTML. Well, that's basically it. So pretty much the same as the template project I showed. And let's dive a bit into, well, let's say the session repository. So this is a repository that has all the sessions at conferences in a DynamoDB table. So, well, this looks comparable, I'd say, to any repository you do in Spring. I'm using the DynamoDB API to do requests, get stuff back. Well, not super interesting. You can use caching just like you would do in a regular Quarkus app. That all works. You can use injection, yeah, like you would do in your Spring app. All works. The only thing I need to do initially, probably it's not even necessary anymore. The caching library that I'm using, it uses some third-party implementation. Third-party library as an implementation, and this wasn't fully native image proof. So I needed to add this annotation, register reflection. You're basically telling the native image compiler that it needs to include these classes as well in your native image. So probably in the JVM world, these are loaded through reflection or some kind of dynamic class loading. And the native image compiler doesn't know we need these classes. So if you add this annotation, it knows I need to include these classes, and then it worked again. So this was one of the, I think, the only like small native image issues that I had. So I did make it a bit easy for myself. So as you saw, I can develop and test everything locally and then say deploy and go to production. I am connecting to DynamoDB just via a secret key and an access key, basically username and password. That means that my laptop is connecting to the production database because YOLO, I'm the only developer, the only operator. I don't really mind. Probably in like a production scenario where you're a bit more serious about security, you would not embed the username and password of your database in your native image, but you use some kind of IAM role or something to configure it in the environment. Well, I'm lazy and it works. So some experiences from running in production. So I put this live right before JSpring last year. So we've had 2 JSprings now, 1 JFull and 1 TechNation. So looking about monitoring, these are some metrics from JFull. You see the amount of invocations that I get. So it was called like 300 times in an hour at the peak. How long it takes. We'll look at a bit of those graphs in a bit more detail. Concurrent executions, max 17. So it's scaled to 70 lambdas in parallel. So number of invocations per minute. Well, you see some interesting peaks here. Here's a peak at 10:30, which is probably right after, so we're talking JFull last year. Probably right after the morning keynotes, when everybody starts voting on those keynotes. There's one here when lunch starts. This is at the afternoon keynotes. And then there's a huge peak here at 4:55. I don't know what this is, but I expect it's someone who works at a large company who asks all their colleagues to vote on their session, and they all vote together at the session. That's the only way I can explain this. The request duration, the average is orange. So the average is pretty much below here, right? So there's some orange here, where it's 500 milliseconds. The max typically stays under 1 second. That means that even if there's a cold start, the vote is still processed within like 1 second. And the max is around like 2 seconds. If we smooth this out, you see that the max is typically around 1, and the average is typically around, I don't know, 30 milliseconds or something, like fast enough to wait if you register a vote in the app. Success count, only successes, no errors. Concurrent executions, well, there's some spikes. So it scales to 8 and then to 4, and then here's a peak. This is in the afternoon to 14 instances. What's interesting that here at 8:30, it's scaled to 16 instances. At 8:30, there's not much going on at JFull. So we have the early bird sessions that start at 8, and then the opening starts at 9. So around 8:30, 8:35, the first early bird sessions are done. For some reason, Lambda got scared because probably some people, session ended, some people started voting at the same time. And then Lambda decided, oh, this is going to be crazy busy, I'm going to scale to 16 instances. So I showed these graphs to the Amazon Lambda team at DevOps UK. And they said, yeah, probably there were like, I don't know, 10 people who pressed vote at exactly the same time. And we thought, wow, there's going to be millions and millions of votes, so we need to scale to 16 instances. And then it found out that this was a mistake. Boom, back to 0, right? So you do see it's getting back to 0 quite often here and there. Well, logs, you can view the logs using the get logs command or just the logs in Cloud Watch, which is Amazon's like default metric monitoring stuff. It's interesting to see here, here's like a cold start, and that took 172 milliseconds, so 0.2 seconds. And here's a warm start that took 2 milliseconds, which I think is acceptable to wait. You know, as a user, if you need to wait 2 milliseconds, probably you're okay. Probably you're okay with 172 milliseconds as well, right? So costs. So it used to cost like around $50 a month before, mainly because of the load balancer that sets you back like 35 and then a couple of small instances. So here's a graph of the costs, and you see that November was a super expensive month because in November it cost double of October. But the units here we're looking at is dollars, right? So it was 8 cents, which is okay, you know, to run a conference backend app, I'd say. So it's S3 which is like 3 cents, and then API gateway. I think you get like 1 million requests for free, so there's a free tier as well. CloudWatch 4 cents, probably because I have 4 alarms configured and an event costs 1 cent per month or something. But still, this is okay. So is this the holy grail or Graal? No pun intended. Well, there are caveats. So if you need to cross-compile across CPU architectures, that's super slow. So for me, it clicked once I could do ARM here and ARM there. You don't get guarantees for third-party library support. So in my case, the Quarkus cache implementation that relied on some third-party library, that third-party library wasn't fully native image proof. But this is a year ago, so probably it's fixed already. The Quarkus, all the Quarkus standard libs are pretty good. Reflection and native image can be tricky. You cannot do dynamic class loading, you cannot do reflection, so you may need to instruct the compiler a little bit to do this. If you have a problem that doesn't surface on your local machine, debugging can be a bit painful because you need to do a build and deploy like 1.5 minute time setback and see if it works in production. On the other hand, on your current projects, can you go from a commit to testing on a test environment in 1.5 minutes? Who can do this? 1.5 minutes is pretty okay, right? So I had some issues with, I think, with HTTP headers, with API gateway when I was configuring authentication. So locally, it's just the Docker container that runs my app, but in production, there's an API gateway in front that may like mangle HTTP headers, or URLs may be different because it's proxies. These are all like problems you can have with a load balancer or proxy in your cloud provider as well. It makes sense to put some limits on your Lambda as an API gateway, because if somebody says, well, 8 cents is really not a lot, let's create a script that sends 1 billion requests to this API gateway, it may be a bit more than 8 cents. So you can throttle, you can set limits there as well. Well, maybe a good idea to use build and deploy pipelines. In my case, just build, deploy, get coffee, and it works. But if you're the only one, then who cares? I don't care. So let's wrap up. To summarize, doing serverless Java, I think, is totally doable in 2024. Quarkus and GraalVM love doing serverless. You can do native images with Spring nowadays as well. Haven't looked at it, but it's doable as well. It's ideal for small or hobby-like projects like mine here. As usual, your mileage may vary. It depends on what type of logic you have, what type of libraries you use, what you're using for persistence. So in my case, I was already using DynamoDB, and the DynamoDB client code was already compatible to run in a native image. If you want to get started, you can go to my GitHub, github.com/BertJan. There's a repository there called Quarkus, GraalVM and AWS Lambda ARM64. And the only thing you need is an AWS account. Configure your AWS CLI. It says it all in this repository. You can get started by deploying your stuff right away. So I want to do one final test of the app infrastructure. So if you can all grab your apps from your pockets. And then go to sessions and scroll all the way down. And then vote for the session. Be honest, but also be generous. I'm voting. It was pretty fast for me. Was it fast for you? Nobody's listening, right? So just screw you, I want to get a beer. Which you can do in about a minute from now. So that's it. I hope you had fun or learned something or both. Please go kick some ass with your newfound knowledge. Thank you and have a great time and drinks.